And welcome back everybody to another layer by layer tutorial. In today's tutorial, we are going to continue with the feather box project. For those of you that are not aware of the feather box project, this is part 3. It is basically a multi-purpose enclosure for the feather line of Arduino compatible boards from Adafruit. So in the first video, we talked about the idea and we sketched out a couple of different concepts, and we modeled a couple of different things and ideas. In the second version, we had more of a enclosure, and we were working and sorting out different ways to handle the battery compartment. So the idea is this enclosure is a multi-purpose enclosure. It's divided up into 3 different portions. The first topper is different types of toppers will be designed for different cases. And then the case itself will have different variants where it can have different mounting tabs on the side. And then it will have a bottom compartment for holding a battery and a slide switch and other things like that. So this is what we have today. We have, these all kind of look the same. Obviously this purple one looks a little bit different because it has mounting tabs. But the main thing is that these are kind of derived from the same CAD file. As you can see it up there. So we'll walk through the CAD file and show you guys how this is put together and how you can modify it with just a simple change to a value in the parameters window. So the main things about the project is that you can make quick adjustments via those user parameters. It is templated based, so you can work off of the sort of master file and then kind of tweak it a little bit from there. And it's basically adaptive, so as you change features, as you change values, features will kind of adapt with the design. So we set that up and we'll take a look at that. So these are kind of the 4 different ones that I just have right now. Again, the feather boards all have pretty much similar mounting holes in the front, but they kind of vary a little bit from the back. So we'll take a look at that in a second. So let's talk about this topper cover. So while I was coming up with the topper, I kept running into problems where I wanted to make a specific topper for a specific wing, notably this guy here. So I wanted to kind of hide some of the things and only expose some of the components. I ran into a couple problems with that, so I ended up making this sort of generic topper wing, and it basically exposes the entire wing. So that makes it so that we can have all sorts of different wings. If we don't want a wing, no worries about it. If you do have a wing, it's exposed. Of course, we'll also have a topper that completely covers the whole thing if you want to enclose it, if you want to enclose the whole circuit. But I think it's nice that you have access to all of the buttons and any of the pinouts that would be available here. So it's still self-contained. Another feature on the case itself is that, of course, we have access to the USB ports. This is micro USB ports. You can use this port for charging the battery if you do have a battery. If you don't have a battery, you could use it to reprogram the board, obviously. So inside this enclosure, so the way the topper works is it has a bit of a locking mechanism. So to pull it out, you kind of have to dig your fingernail in between these two like that and pop it out like that. You'll see here that it has a little lip, and in the lip there's an indentation. On the edges on the top of the enclosure are these little nubs which fit nicely into these indentations on the cover. So it's sort of a locking mechanism. There's also a little lip here that runs across this edge here for exposing the wing, but you'll notice there's a tiny little cutout, and that cutout is to give space for this guy here, which is the JST connector for the battery. Okay, so that's the topper, that's the case. The next part of the design is, of course, this guy here. So this is a separate piece, and this houses a battery, specifically a 2000 milliamp battery. It has a similar mechanism. You can see I can kind of pull it apart, but it is locked in there pretty good. There's a little bit of leeway, and that's just to kind of alleviate, to kind of combat different tolerances that might happen. So that's why it's a teeny bit loose, but it is locked in there. You don't get much wiggle play from there. What I find a way, I can't really get my fingernail on there, so, or at least I can't pop it off, so I use this little flat piece of the tweezers here and just kind of pop it out like that. You probably heard that click. That means it came off. And then just do the same for that side. So let's go look inside here. Inside this compartment is, of course, the battery. So it's a 2000 milliamp battery. It could also house a 1500 milliamp battery. They have about the same width and length. They just have different thickness. So that's the 2000 milliamp battery. All this wiring here is for the switch. So there's a little switch here that can turn the battery on and off. And wired to the switch is a male and female JST connector. So the idea being that you can disconnect the battery easily. We could have soldered this switch in line with the connector from the battery, but I'm not a fan of cutting wires from the battery. Of course, you could do that, but I don't like to do that too much. In the bottom here, you can see how the feathers being mounted to this case here is being mounted with these two screws. These are 440 screws, or you could use M25 screws if you prefer. You could also use nuts if you want, but these 440 screws tend to have a little bit of bite to the mounting holes, so they work pretty well. In the back here, you can see that there are slotted holes, and this is to accommodate for different variable sizes. Yeah, so some of the feathers will be a little bit longer than others, but they all have the same mounting holes for the top here where the USB port is. But the back here is where it changes. So having these slots allows you to mount different types of boards. This was actually an idea from Bill Binko, who inspired this project as well. These little holes here on the side, these are obviously for these little nubs that are on the battery holder. So if you look carefully at this profile, you can see they protrude out and then inward. So it has that little triangular nub, so that with that triangular nub, you kind of combat overhangs from the 3D printing process, so you don't have any stringing stuff. So it works pretty well. And of course, the way it snaps in and it locks like this. And then this side clips in, it's locked in place. Let's talk about these guys here. These are winged tabs. Feather wing tabs. Haha. The holes are about 4 millimeters in diameter. I'm not too sure what the distance is from these two guys, but there's obviously a distance to them. The point of these guys is to be able to mount this whole assembly to any surface, to a wall or to another project. You have these mounting holes. These are optional. You don't need them. You can see on this version it's not there. Same case, but just doesn't have the wings. I also have a version where the mounting tabs are on the case. So you can see this is the case in its slimmest form. There's no battery compartment, and it has a different topper. So the topper has mounting holes for mounting this large piezo. There are some projects that might need a piezo and only a piezo and not a feather wing. Same topping mechanism where there's an indentation there and the nubs here. This isn't wired to anything, and then there's no board in there yet. It's just kind of to show that you can have different toppers for this case. Okay. Another feature of the case is you'll notice that there's a bit of an opening here. And what this is for cables or wiring that you want to have external. So you can imagine jumper cables coming out here so you can access some of the pinouts. Or of course, if you didn't have a wing, you could do that too. You can have access to the top of the wing. But this slit here is so that you don't have to thread any cables through that hole. If it was just a hole with the closing here, then you would have to kind of thread wires. But I think it's a nice feature to have this completely open so that you can easily get wires in and out of there. So if you're wondering why there's a little bit of gap here and not a gap there, it's to accommodate for the size of the battery. So if you look at the battery here, that's about the size that you can get. There's a little bit of play here and here, and that's just so that you have option to put something here, maybe another battery, a button or something, and of course to be able to remove the JST connector here from the battery compartment. So that's why there's a little bit of gap there. All this is parametric, so you have the option to increase this or decrease it however you want. So that is that piece there. They all have it. They all kind of have it. It's not really destructive or in the way, so that's why all of them have it. They don't need to have it, but I thought I'd leave it in. So let's take a look at this one. So there's no battery compartment, but it is on, and it has just about the same features, but there's a little bit of extra things. So this is the slide switch, so I can turn off and on. Well, where's the battery? The battery is inside this case. If I take the cover off, you can see where the battery is. If you don't need a 2000 milliamp battery, you could use a 100 milliamp battery. There's enough room in between these two edges here for a small battery. Everything else is just wiring. I could cut the wire and make it smaller and slimmer, but it's nice to have this little bit of free space for wires. So that's how that's working. So if you really want a small portable project that's not too power hungry, you can go with this option. I'll also have a version with winged tabs so that you can mount it to something if you want. On the bottom here, you can see I'm using different screws. These are M25 nylon screws. They don't really bite into the board, so if you look here, you can see that they are little nuts. Yeah, they're little hexagon nuts that kind of hold the board to the bottom of the enclosure. Pretty cool. So those are all the different versions I have so far. Now, one of the things I wanted to talk about was how I got the slide switch to kind of work with the battery, right? So they all have this slide switch. What does the slide switch look like? This is what I'm calling a slide switch adapter. You might have heard me and Pedro talk about this. This little component here is something that we use a lot in our projects, and it's just a way to get a slide switch in between a battery and the feather board. So this is an assembly that does not come like this. This is, I hand soldered this and cut the wires and measured it out like this. So you kind of have to build this thing. Though one of the things, it does require quite a few steps. I'll probably make a video on how to make these little guys, but it's basically a female JST connector and a JST extension cable. You cut the two, and then you wire these things together like that. So if you kind of look at it this way, it probably makes more sense. It's just a male JST cable, and that is the female JST cable, and in between the positive connection is this switch, so you can close and open the circuit. So that's how that works. But if you're thinking, well, I don't want to solder this, and I don't know how to solder too much, or I don't want to solder, we do have a JST extension cable, right? So there's a male JST connector, female JST connector, and in the middle is this massive, nicely, listen to that click, love that click, nice big button. The thing is though, I don't have a way to mount this button inside the case. It's a little bit big. It's actually bigger than the case. So what I ended up doing was making holes. You see these holes here. I ended up making holes on the left and the right so that you can mount it in this position external to the monitor, and then you can just kind of either have it in place with friction or stick something here to the case. So if you don't want to kind of make your own slide switch adapter, we have a solution that's already pre-made for you. And I think what I can do is probably assemble it too. So let's take a look at how it's, actually I already have it assembled. So I already have this piece here. See the two screws that are holding this wicked feather. Is it a wicked feather? Feather M0 Wince with the Bluetooth Wi-Fi chip thing. So it's a little bit bigger. So what you would do is, here's the battery compartment. There's no slide switch holder because we want to use this guy, right? The switch. So all we have is a kind of a opening slit on the side here. So if I put battery inside the case, then I plug in the JST connector from the battery to the female JST connector. Let me make some room here. I kind of thought about having this pre-assembled, but I kind of want to show you how it's kind of assembled. So that's set up already. So what we do is we plug in this JST connector, the male one, to the female JST connector. It's just like that. There's enough room for your finger to get in there. I'd like a little bit more room, but I think it's okay. My fingers aren't that okay. So I just kind of route this around until I'm pretty close. So you can see kind of how that is. Just kind of fit that long wire in there. And then we'll kind of do the same for this area here. You kind of want to kind of fit the wire as best as you can into it, obviously. There is just enough room for everything to kind of squeeze. So hopefully we'll get it like this. And then what I'll do is connect it to the bottom. I kind of want this oriented right, so I need to have this oriented this way. Snap those two together. Now I have to worry about is futzing with this extra excess cable here. Maybe we can just kind of force it like that. And I need the topper. Here's the topper. Obviously I could do it a little bit better, but that's kind of the ideal easy way to do it. Obviously I could have tucked this wire behind this header, but hey, check that out. I got a really easy way to turn on and off the whole circuit. Yeah, obviously I could work the battery cable a little bit better, but that's kind of it. It's held in place. You could secure it to it with some glue or some foam tape or something. So that's it. If you want, again, this is the nicest way, I think. You do have to solder and do a couple steps. If you don't want to make that, just use this guy and use this version. Of course, I'll make a version with wing tabs if that's important to you. The whole point is to have just about every type of configurable scenario. So hopefully we nail all those. And what I'll do is probably open some sort of discussion on the Adafruit forums so folks can request custom made ones or ideas and things like that. I'll ask you guys in the chat room that are watching live if you guys have any ideas. So we'll work on that a little bit. So the next thing I want to talk about is kind of the parameters, the user parameters inside of Fusion 360. So this was just kind of showing you physical, what it looks like. Let's jump into CAD and show you how we can modify some things. Obviously, you have to switch the camera like that. All right, so here's the CAD file. When you first open it up, I will kind of publicly share this so folks can make their own modifications. Though if they don't want to, I suggest that they post up in the Adafruit forums if they want a custom made one. So here's kind of the work through from the browser looking at the main assembly. We have different types of components. So we have a Feather OLED, which is sort of a reference point just to kind of figure out as a generic wing that has components on it. That helps us see the space between the feather and the feather wing. The other thing we have in here is a slide switch, which is at the bottom here, and we have other components like this large piezo and things that are turned off. So I don't really need to work with those. So don't really worry about too much of those. We can turn off these components if we want. The main thing we want to see is our bodies that are inside. You can see there's a bunch of different bodies. So this is, I'm trying to find out a better way to manage these guys. Maybe put them in their own components, but for now, to see them all in one folder, I think is okay. I try to name them as best as I can. So like this top here, let me hide everything and just kind of show it one by one. So this top here has these little, actually this is something I'm working on. It has little buttons, little holes for buttons, and little mounting mechanisms for buttons. It's not fully baked. So that's one thing I'm working with. And then there's of course the case with the hole on the side here. I still need to work on a better naming scheme for that one. This one has the slide switch, or no, this one has a little bottom hole for the battery. And here are all the battery holders, so they're all called battery holder. This one has the wings. This one has no mounting tabs, but a hole on the side. This one has no tabs, but a mounting hole on the side. So obviously there's opportunities to come up with some good naming schemes for them. Here's one with just tabs on the side. Here's the topper with the button mount over here. So there's a bunch of different options, right? Here's the piezo one. Let's just kind of open up the generic one. Really, they're all derived from the same copy. So they all will update when we update one thing. So I'm going to open this one. It's the case battery, and then maybe the battery holder, the simple one, and then the topper. So what I think is, so this is kind of like your basic kind of assembly, right? Just these three guys, right? So when I open up the change parameter windows, we have a couple parameters. The first one I want to talk about is case height. So right now it's set to 10 millimeters, and this is the height of the case, not the battery compartment, but just the case. So because this topper is derived from the case, I should be able to update this, and hopefully the features will adapt to the change. So let's go ahead and change to 20. You can see it's computing on the bottom here all the different copies, because it has to sort through all of those copies and update all the features. So you see the case is way bigger now. And if we look at the features top down, we can see that the nubs from the case, the indentations from the topper are kind of all updated. They've adapted to our update. And you'll see that the slot is now like super slotted, right? So that slot has a constraint where it's saying that the top of this should be a collinear along the edge of the top here. So that's why it updates with it. You could change that, of course. We can jump into the sketch and update that, or perhaps we can even make it into its own user parameter. I didn't want to make too many user parameters, just kind of the main ones that make sense. So let's bring this back down to 10. One of the reasons why you might want to have a taller case is to completely cover up your feather, right? So if we open up the regular feather, you'll see that it has some pretty tall looking female headers. So these guys right here are the female headers, and they're just about intersecting with the topper. If I didn't have this opening for the wing, it would kind of intersect, and you wouldn't be able to close the case all the way. So this is really the thinnest I could get it. 10 millimeters is pretty darn thin. The standoffs elevate the PCB just about 2 millimeters above from the ground, and that's just to kind of give some clearance so that when you have pins soldered on the bottom of the feather, they won't hit the bottom surface of the enclosure. So that's why there's a little bit of elevation in those standoffs. Okay. Now the next thing is what I call margin right. So if you look at your view cube, you can see the right is over here, right? So that's called right. And there's a little bit of gap again from this surface to the edge of the PCB. So there's a little bit of gap there, and again, why is that there? It's because to accommodate room for the battery, the 2000 milliamp battery. So if you didn't have that, you could change that parameter. Right now it's being driven by a kind of projected sketch from this battery component. So I kind of would have to rework it a little bit. So there is still some work to be done where that feature is being derived from the PCB and not the battery. So that makes more sense. So I still have to do that. So I could add more margin. What is it, 2? What if I make it 10? Let's see what happens. What will happen? Looks like everything's okay. I don't have any orange red warnings, so you'll notice that the topper indentation and the nubs are kind of made with a center based rectangle, right? So the idea is that they're always symmetrical, so you could kind of install the topper, there's no wrong way to install it. Of course, if you didn't have this topper, if you didn't have the feather wing opening, it would be symmetrical. It doesn't matter which way, because it's always centered to this surface here, so it's always in the center. Another thing you'll notice is that this hole here, the little slit for external wires, updated as well, so that's cool. So if you needed to elongate the enclosure, you can do that relatively easily. So I'm going to set this back to 2. It takes a little bit to compute all those copies, but not too bad. So there you go, it's back to 2. Let's see. Another thing I have is margin sides. So we have margin right, which was this guy, but margin sides is basically this top area here and this area there. So if you needed to have more clearance from the edge of the PCB to the edge of the case, you could just increase this value. Right now it's set to 12, but we can increase that to 20. Hopefully things don't break. Again, fingers are crossed. You can see in the browser how all these copies are being updated. Looks like there is a broken stuff here. You can look at the timeline. There's warnings, there's errors. Chamfers are all going all wrong over the place, so I will have to kind of go back, revisit this, and figure out. I don't see anything physical because Fusion does a good job of kind of, what is the word? It kind of caches some of the geometry. But in this case, it looks like it's not too bad. There's a little bit of work there, but I don't see this being changed too much. So that's why I haven't really thoroughly tested it, but I just wanted to show you there that I have that as a concept. We are kind of ideating that. So let's bring this back to, I think it was 12. I hope it was 12. I'm just going to close it and don't save it because I already have it saved. All right, I think it's 12, yeah. Looks like all the errors have cleared out. So there is a little bit of work to do there to kind of optimize the way the user parameters are set up, and of course also to set up and optimize my timeline. If you look at my timeline, there's a lot of stuff going on there. I think there's opportunity to kind of cut the fat, as they say, to try to do as much with as little features as possible so that there's not this long thing. Another thing to do is to group certain segments, but in order to do that I have to kind of rework the order of operations so that they make sense, so that I can group them, and maybe I would group different toppers into different segments here in the thing, or put them in components, because when you use components they tend to encapsulate their own features in their own timeline. So there's still things to do there. Let's see, what else do I have here? Yeah, so there's some extra features I don't think are necessary. The thickness of the case, I have it set to 1.5. You could set it to 2 or 3 or something like that if you wanted a really thick case. I don't see that being used too much, because I think when it's 3D printed, it's 3 perimeters of a shell. So there's just 3 perimeters being drawn for the wall thickness. So that tends to be pretty strong. I don't think you need to have it any stronger, but I have it there just because. Another extra is this case fillet, which is just the rounded corners on the edges. You could change that, I guess, if you want. I don't see that too much. So those are kind of like the extras, right? Okay, so the next stuff I want to talk about is design modifications. So we can just kind of leave CAD alone for a little bit. I got notes here, so just kind of walk through them a little bit. You'll notice that the feather isn't really centered, right? I kind of have OCD when it comes to design, and if things aren't centered, it kind of makes me feel bad. But I'll tell you why the feather is all the way to the right here. It's because this USB port, the further inward you have your USB port, the more opening you need for the port. So if I show you, here's a cable, right? You can see that most of these USB cables have a pretty beefy connector, and that's for strain relief and just to be able to hold it. So once I insert it in, you can see that there's a little bit of an indentation there, right? So that indentation allows this just to snap right in there. And if I take this topper off, you can probably see. Probably better to do it this way, because then you can actually see I don't have much room here. So I need to come up with a solution so that this guy can be embedded into the case more. This connector can kind of go more inside there and not just have this giant opening, because right now the opening is kind of made just for that USB connector. We've made projects where you have like this giant hole and then your whole thing goes inside the case, which is something you could do. So there's that. I don't think it's too much of an issue, but that is something that I wanted to talk about. Maybe y'all know a good solution for that. Another thing I want to talk about was to have variable case heights. So I'm thinking a slim, medium, and a tall version. So they're kind of like these presets where you can kind of have different heights without having to jump into CAD and modify a user parameter. It'd be nice to just have them available. So I'm thinking this version would be slim, the 10 millimeter version, and then maybe a 15 millimeter version and maybe a 30 mil version that encapsulates the whole case. Here's an example of just like, yeah, that thing's way out there, right? This is like double the case, so it's like 20 millimeters or more, and that's just because this 7-segment display is just so thick. What's another thing I want to talk about? Oh, some of the easy things to do is to add fillets or chamfers to these edges. It's pretty sharp, right? They should feel soft, so adding a fillet to these edges is something I can do, very easy to do. I haven't done it, but I need to do that. Another thing I want to do is to make these wings parametric. Right now they're not parametric, so I think it'd be cool to have the ability to set the value for the distance between these two holes, and then when you update it, this geometry grows with the value change. Right now I haven't driven it the right way, so I kind of need to do some learnings on the proper way to sketch this shape, because right now if I move the shape it breaks, so I need to sit down and learn how to do that properly. I talked a little bit about reworking the master assembly. That's just the browser, all the layers inside the browser and the sidebar. So I just need to make it a little bit more better for people to come in and quickly understand where things are. I kind of need to take a close look at versioning and see if that's something that I could do. I know Fusion has versioning capabilities, but how that makes sense with this project is something I have to look into. I talked a little bit about reworking the timeline, optimizing features to reduce them, grouping features in the timeline so that they make sense, organizing features without breaking the order of operations, so kind of making the pieces of the enclosure make kind of like a generic, sort of a central version, and then make copies from those master versions so that it's easy to make another copy and to just to be able to get into the timeline and understand where things are, right? Let's see, what else do I have? There's some other notes here that's just kind of like tidbit things. I think we kind of tested, so testing tolerances is another thing, different material. All this has been PLA. I have a couple folks that that we're going to try out different materials like ABS and PETG and things like that. So how do those translate? How do these features and snap fit tolerances translate to those materials is yet to be tested. So that's a big thing. If we can kind of make versions or just have a single version that works across all of these different types of filament, that would be ideal. I'm not sure how well that'll work though. I think that's it. That's basically it. That's all I want to talk about. I'll kind of open up the chat here. Let's see if we can do it this way. And hopefully Pedro's been answering a lot of questions. So if you have any questions or any suggestions and stuff, you can leave them now, or later in the pre-recorded show. So let's see, where should I go here? Yeah, something like that. Greg wants a TFT topper. The feather is in a very not odd shape, but it's in a shape where I don't think we have a TFT that's this shape. The OLED is in a good shape, but I'm not sure how a TFT. Maybe we can get a custom-made TFT, or find one that's like this kind of rectangle, elongated rectangle. James is saying that ABS would be your biggest issue since it has serious shrinkage issue. I agree with that. It can shrink quite a bit, and sometimes the tolerances have to be doubled. So like what I tend to do for friction fit tolerances is I have a clearance of 0.02 of a millimeter, but I think with ABS it goes to like 0.4 or maybe even higher. So that is definitely an issue. Yanni is saying if the design in NinjaFlex, that whole case, so we can hold it, also keep external wires good and limit the stress to the connections. That's a good idea, using NinjaFlex to kind of act as strain relief for any wires. That's a good idea. Grog in the chat room is saying he would check the expansion and contraction rates for the different materials to set better tolerances. But yeah, it's always going to be a trial and error. So maybe one thing that's worth doing is to set the tolerances as a user parameter so that you don't have to go into a specific sketch and update those tolerances, because that is kind of currently how it is set up. Pedro, I think, is in the chat room saying we do have a 2.4 TFT feather. I did not know that. Oh my goodness, we do. Look at that. Oh, look at that. Yeah, this will definitely require its own case, because it's a square. I forgot we do have a TFT. That's great. I just completely forgot about it. I don't think I saw it listed in the feathers part. It's got to be listed somewhere. Anyway, this is something that definitely needs a custom case for it. But I think it shouldn't be too hard to work from our template and then just kind of put in the right values so that the case covers the whole thing here. Kirby's saying that is this for tolerances? I think he's referring to the tolerances discussion about setting his steps per millimeter of the printer to a certain value so that more or less of material is being printed, I think. It has to, and also different flow rate multipliers. So maybe that's the solution, is to just tweak your settings a little bit in your slicer for the 3D printer to accommodate for these certain tolerances, these snap fit tolerances. That's a good idea. Yes, James also agrees. Versioning will help with this. Yeah, I hope that is something I need to look into. So I'll do some research there. Cool. All right, well, that's where I'm at with this project. Again, I want to give a big shout out to Bill Binko, who inspired this project. If you want to check out Bill Binko, it's AT Makers. And you're interested in helping folks who need assistance. So this is assistant tech. assistive tech. You can help folks in need. If you have an idle printer, you can help folks make these type of projects. I'm just reading the chat room. That's why there's silence. Cool. Well, that's going to be it for me. Definitely let me know what you guys think in the show, the pre-recorded show, because that's a better way to digest comments. But that's where we're at right now. There's still a little bit of work to do. If anybody wants to test this out right now, I'll be happy to send you the STL files or send you the public shared link. I don't want to release this just yet because it's not fully baked and it hasn't been thoroughly tested with all the things that we talked about. But I think we're working pretty good. A lot of progress is being made on it. And that's it for me. I'm going to keep working on it and doing some more research on the versioning and other things like that. But if you did find this video useful, be sure to check out all the other tutorials. We got playlists and those things. There's lots of links down below in the description for more of these type of tutorials and things. What happened?
You still going?
Yeah.
I got something new for you to test out.
I had it all this time. I forgot I had it.
We're out of stock, but luckily...
Yeah, I mean, we tend to have one in stock, or in-house, so that we can play with it. Cool. Well, Pedro it's got me even more work to do. This is great. It's like as big as the enclosure. But it goes like that, yeah. Oh. So, cool. All right, cool. Folks.
Yeah. Look cool, though.
We'll see you guys tomorrow on 3D Hangouts. It's on at 11 a.m. on Wednesdays. Yep. Lots of shows tomorrow. So, good luck, everybody, and we'll see you tomorrow. Bye, folks.